Hello everyone, welcome to our dissection of the cow eyeball. We are using this as a little comparative anatomy so that we can better understand the human eye. There are some differences between the cow eye and the human eye, and we won't be able to give you quotes on the differences in size, but we can tell you that the cow eye is just a little bit bigger. We want to take a moment to give you our public service announcement. If you are watching this video in preparation for doing a dissection at home, or if you're in the lab and just very poorly supervised, please make sure that you take the initiative to wear some safety goggles, because the eye dissection is notoriously one of the most messy and potentially perilous. Today, I'm going to start with giving you sort of an overview of the exterior of the eye. So the external structure, you might be noticing, what in the world is that white stuff? This white stuff, friends, is the fatty adipose tissue that is the big protector of the eye. This is what keeps this delicate and valuable sensory organ from coming to harm when it's between these bony structures of the orbit. The other thing that we are lucky enough to have here, I have two eyeballs today that I'm working with. This one we kept because it was the most valuable to us, because it does have the musculature here. This is one of the remnant of this cow's extraocular or extrinsic eye muscle. So this is one of the muscles that allows the cow to mobilize the eye to look around and get a different view of things. With the cow, some interesting factoid here is humans have 6 extraocular muscles. Cows have 4 extraocular muscles. The thing they can't do, which is a real bummer to teen cows, is they cannot roll their eyes. So they can look up, they can look down, they can look side to side. Humans, having those 2 extraocular muscles, are unable to roll their eyes. We use that a lot in our sarcasm and teen years.
Yes, and our teenagers use it all the time.
Indeed, and we love it. So, the next thing we're going to be going into is the sclera, is the white part of the eye under here that is going to be the attachment point for these extraocular muscles.
It's very strong and fibrous.
Made of mostly collagen. Okay, folks. We are skipping ahead on your behalf, so you didn't see us doing the hard work of removing the fatty tissue from the exterior of the eye. Now we have done that and liberated the eyeball for you so we can show you the external anatomy. We start here with our most obvious structure of the cornea. The cornea is the outermost protective layer of the eye. You can see when I press here that the cornea actually is going sort of recessing and expanding, recessing and expanding. That is doing so because there's a pool of fluid in the anterior portion of the eye that is called the aqueous humor, and that is a watery-like substance which bathes these anterior eye structures. That also helps to hold the shape of the front or anterior portion of the eye. So when we're looking at this is the cornea. You might be wondering, hey, that cornea looks really cloudy and dark. How does this poor cow see? And the answer to that, folks, is when this cow was living, this structure would have been slightly softer and much clearer. So the other thing to note is when we move towards the posterior surface of the eye, this is our optic nerve. Our optic nerve is where the magic happens between the brain and the retina. So this is going to transmit visual information from the retina, where we have our photoreceptors, to the brain itself. So this is the transmission out of the eye where we're receiving this sensory information to the point where we're going to make sense of that sensory information. The other things to notice, a couple more things on the exterior surface of the eye. We have the sclera. Now when you look in your textbook, the sclera may look a little whiter and less gray, but this is indeed the main component of the fibrous tunic, or the outer layer of the eye. The fibrous tunic of the eye is named as such because it's fibrous. It's made of lots of collagenous fibers that give it a little bit of a stronger structure. Why we care about that is it's an extra protection layer for the eye. It also serves as a strong and firm attachment point for our extraocular muscles, which we had looked at in another view, and now we see here attached to that sclera. Okay, we left that on for you. So this is the external of the eye. The three things, again, are the optic nerve, the sclera, and the cornea.
Oh, there's the liquid.
Okay, folks, you can see as I made my first cut that we are getting that aqueous fluid. It's aqueous, watery, you get that connection. Much more watery than what we're going to see with the vitreous fluid. Now, if you're still watching, you're going to note that, as I mentioned, the cornea is a little bit crunchy when in a non-living specimen. So I'm going to remove the cornea. Whoop, that's the lens, folks. Okay.
Just pops right out. While you're looking at the lens, you will notice that the lens is also a amber sort of color right now, but the lens in a living specimen is also quite clear.
It's still nice and firm, right? And you can see that it now is a little bit more pliable than what it looked when we were first working with the intact structure.
It's much tougher and thicker than it looks.
Exactly, and so when I'm pressing, you can really feel that it's a good source of protection, and this is going to be an important point where light first makes its way and bends back toward the back of the eye, where we're going to make sense of that stimuli. This is the lens. The lens in a living organism is going to be very flexible because the lens is used to do a visual accommodation. It is going to move to become a little tighter or a little wider depending on whether we're looking at something close up or whether we're looking at something far away. So that's a key function of the lens, is accommodation. The second function of the lens is back here where it would be living, right behind the iris. When we look at the cornea is the first bending point of light. Then we have the second bending point or refraction point is the lens itself. I'm going to take the lens back out. So when we look at this next portion, I'm probably going to cut away, and we're going to see the part of the iris here, which is part of our vascular tunic of the eye. Okay, folks, we are now taking you to the interior of the eye, more so than we were before. We looked at the anterior cavity portion for a moment, and we'll go back to that. But we cut the eye a little bit towards the central part so you could better see the posterior surface of the eye. The thing you might be noticing here is, wow, what is that fluid pool in the back? And this is our vitreous humor or vitreous body. So you see that this looks a little bit different than the aqueous humor that we had observed on the anterior portion of the eye. This is made largely of protein and water, and it's kind of like an aloe gel. If you've ever put aloe on a burn, it has that sort of similar consistency. Its main job is to hold the shape of that posterior portion of the eye. I'm going to remove that for us. The vitreous was actually pretty tough. It was hard to get out of there. Now we are really lucky because I'm going to demonstrate for you. This is the anterior most portion of the eye, looking at it from posterior to anterior, okay? So this portion that you see here, this is the iris, okay? It's still got some vitreous stuck here. But the iris is going to be, these are radial muscles that are going to expand and contract, or they're going to let more light into the eye. Here we are looking at the pupil, okay? So this is the opening that is either going to become smaller in the case of high light exposure, or larger, it's going to expand out in the case of low light exposure like the dark. So that's going to allow us to kind of choose how much light we're letting towards the back of the retina for optimizing our visual sense. The thing to note is, this is the iris itself is part of the vascular tunic of the eye. Lots of blood vessels actually that supply this part of the eye. And again, this is going to be a muscular part of the eye, smooth muscle that is the function of which is dictated by our autonomic nervous system. The other thing to note here is when we look at the pupil, you might be thinking, wow, that's a weird oblong looking pupil. In the cow eye, it actually is a little bit more oval, whereas if we were looking at this in a human specimen, you would see that the pupil itself was a little bit more round. It's an interesting comparative anatomy fact. Now I'm going to move that aside so that we can look at the posterior surface of the eye. Now, I'm going to remove, we have choroid. Choroid is another part of the vascular tunic, that second layer of the eye. When I move the choroid out of the way for us, sorry, you're getting a lot of view of my hands, but you're going to notice, wow, what is that delightful iridescent color at the back of the eyeball?
It is beautiful.
Now, this would be right in front of the retina. In the human specimen, you would not see this, but in certain mammals, for example, the cow and the cat, we have what's called the tapetum, and this is the part of the eye that actually reflects back light in dark settings. So it's going to bounce light back in the dark. So that's why when you see an animal at night and your car light shines, or you have a flashlight and you're out camping or something, which I don't do, but if you were that sort, you might see an animal with its eyes shining at you, and that is a function of this tapetum. So now I've moved the tapetum out of the way, and we're looking at the posterior most portion of the eye, which is indeed our retina. This is the spot where we have what are called photoreceptor cells. There are two main types of photoreceptor cell. There's the rod and there's the cone. The rods are going to give us light and dark information. So when we're in low light settings, it gives us a little bit more information about shadow and texture. And so that's where we get our rough, sort of vision in the dark feedback. When we're in a higher light setting, we get a lot more feedback from the cone cells. So these cells are going to help us to differentiate color. We have three types of cone cells: R, G, and B, red, green, blue. Okay, folks, next we're gonna just show you one last point that you weren't able to see really well because we hadn't fully cleared the retinal surface there, but this spot right here, sometimes it's color friendly for you so you can see a little bit of a differentiation, but here we didn't. This is the spot on the retina that is referred to as our blind spot. So this is the spot where the optic nerve begins and exits on the posterior surface of the eye. Again, we had looked at the optic nerve when we had viewed this earlier. So when we look at that connected point, this is where the optic nerve is making its communication beginning with the retina. The reason why that's so important to understand is when we think about our visual sense, and you may do this in your lab classes where you find your blind spot, when information reaches this point on the retina, we are unable to make sense of it. And the reason why is because the blind spot, where the optic nerve exits the eye, we do not have photoreceptor cells. So no rods, no cones. Now our brains, because we are so savvy, are able to bypass that blind spot, and we complete the picture anyway.
Fill in the blanks.
We fill in the blank. So we can give our brain some real props for being really, really adept, because we don't notice our blind spot unless we're really looking for it, like when we do the blind spot activities in the lab. That concludes our dissection of the eye. That's right.
Show's over. Go home.